And we left off last Friday talking about these mixtures and solutions. And I want to take a little bit of time to make sure we go through that a little bit more. So the types of problems we were looking at look something like this. You know, we have two percentages on hand and we're mixing them to get a final percentage. So the question might look like this. How much... Oops, can't see the screen. Let me... So how much 47% solution would you mix with 180 milliliters of 27% solution to create a 35% solution? So to walk through how we set this up, of course, first thing we have to do is identify our ingredients, the two items that are going into this mixture. We have the 47% and the 27%. Really does not matter which one we put first. So we're going to combine 47% and 27%, and we are trying to create 35% solution. Next, we have our volumes. Well, we have 180 milliliters. Goes with the 27%. We're trying to find how much of the 47%. That's our X. So then the amount of the 35% will just be those two amounts added together. So X plus 180. Giving us 0.47X. You put that in parentheses at first. Plus 0.27 for our 27% times its volume of 180 equals 35% becomes 0.35 times X plus 180. So now from here it's just the algebra. I'm going to rush through this because I know you guys can handle this part. So 0.47 times X is 0.47X. 0.27 times 180, 48.6 equals 0.35 is distributed through. So 0.35 times X is 0.35X. And 0.35 times 180 is 63. So plus 63. Now we have an X on both sides. We're going to get rid of one of them again. We're going to get rid of the smaller one, which is the 0.35. Gives us 0.12X over here plus 48.6 equals 63. And then we subtract the 48.6. 0.12X equals 14.4. And our final step is to divide by the 0.12. Which is X equals 120 milliliters. So we would mix, X was the amount of the 47%. So we would mix 120 milliliters of the 47% with our existing 180 milliliters of the 27%. We've done this type of problem before, and hopefully you guys are starting to feel relatively comfortable with them. Now I want to change it up a little bit. We're going to ask the question this way now. How much 18% and 27% solutions, I should say, do you need to mix to create 360 milliliters of 24% solution? So now in this problem, we're given the total amount. This is more practical. Normally, we don't just take we're going to take this much of the 18%. Well, how much 27% do we have to add to it to get to the 24? Normally, we not only know the concentration we want the final product to be, but we know how much of it we want. So in order to avoid waste, we're not going to just randomly pick an amount for one of the solutions and add to it. We're going to have 360 milliliters of the 24%. So here again, we are mixing 18% and 27% and hoping to create 24%. The difference is this time, the amount we have is the 360 milliliters is of that resulting concentration, the 24%. So we need to figure out how to represent the other amounts. Now we could have two variables here, but that would put us into solving a system of equations, and we don't want to make it that complicated on us. So what we're going to do is this. We're going to try to represent them with one variable. What we know, the relationship that we know between these amounts of 18% and 27%, we know it's going to have to add up to 360 milliliters. So I'm going to pick one of the amounts, either the 18 or the 27%, to be X. And I usually pick the larger of the two concentrations, the larger percentage, to be X. So I'm going to pick the amount of the 27% solution to be X. That means the 18% solution, the amount of that will have to be our total of 360 minus X. So now my formula is going to become 0.18 is that concentration times its amount, which is 360 minus X, plus 27% is 0.27 times X, is going to equal 24% will be 0.24 times the amount of 360 milliliters. So now 0.18 times 360. $64.8. 0.18 times negative X is a negative 0.18X. Plus 0.27 times X is just 0.27X equals 0.24 times 360. $86.4. You can see here right now why I chose to make X the amount of the larger percent, because if I had made it the other way around, I would end up with working with negatives here. And I know you guys are all pretty good with negatives, but I try to avoid them whenever I can. So then our next step here, we're going to have to combine the X's. We've got a negative 0.18 and a positive 0.27. That's a positive 0.09X. We still have our 64.8 up here, equals 86.4. Then we're going to solve for X. Subtract the 64.8. So 0.09X equals, what's that going to be, 21.6. And then divide by 0.09. So X equals what? 240? So now we're not done. We do have to make sure we go back and answer the question. X represented the amount of the 27% solution. That's going to be 240 milliliters. We also need the amount of the 18% solution, which is 360 minus X. So that'd be 360 minus 240, or 120 milliliters. So in those types of problems, we have to make sure we go back and answer the question. Now there are some related questions to this that I want to address. We'll come back and do another example of that before we're done as well. Sometimes we run into a problem like this. We have 600 milliliters of 78% solution. So our question is, how much NS, remember NS stands for neutral solution or normal saline. In other words, it's completely inert. There's no active ingredient in it at all, no medicinal value. So how much NS do we need to add to create or dilute it down to 26% solution? So now here, the tricky part is figuring out what the ingredients are. The 78% is one of our ingredients. But what are we adding to the 78%? Well, NS, normal saline or neutral solution. What percent medication is in that? 0%. And we're shooting for a result of 26%. So now for our volumes or amounts, we know that we have 600 milliliters of the 78%. We are looking for how much water, how much of the 0% to add. So that's going to be our X. So then the 26% will be 600 plus X, or X plus 600. So we'll write out our equation again. So this is 0.78 times 600 plus 0 times X equals 0.26 times X plus 600. Now you might wonder, well, why did I even bother to put in the 0x here? Well, I only put that in here just because it helps to show that we have the 600 plus X to get the X plus 600 value. Otherwise, yes, if you left it out, it would not affect anything. So now we have 0.78 times 600. So 468 equals the 0x. We can just leave out now. 0.26 times X is 0.26X. And then 0.26 times 600. 156. So now to solve this, we only have the X appearing once, so it's a lot simpler to solve now than the others were. We subtract 156. That's 312. And we will divide by 0.26. So 312 divided by 0.26. 1200. So X is 1200. Again, let's go up and make sure we've answered our question. Yes. X is 1200 milliliters. That's the amount of our NS, or a 0% solution that we wanted to add. Now this is, again, a little bit different problem because we have a 0% in there. The other side of that would be, let's look at your antifreeze for your car or something like that. So let's say you test your antifreeze at 48%. So the antifreeze solution in your car radiator is 48%. How much pure antifreeze would you need to add to, let's say that this is 12 liters of the 48% to create a 60% mixture or solution? So now in this case, our ingredients, we include the 48%. But now what percent are we combining with it? We're not combining 0%. This is not water. This is actually pure antifreeze. That's 100% that we are adding to it. And we're trying to create a 60% solution. The volume, well, we have 12 liters. I could change it to 12,000 milliliters if I wanted to, but we're not going to worry about that. X is the amount of the 100%, so X plus 12 is going to be the amount of the 60% that we're going to create. So this will be 0.48 times 12. 100% is 1 times its volume of X. 60%, 0.6 times X plus 12. And we solve. 0.48 times 12 is 5.76. Plus 1 times X is just going to be X. Over here we're going to distribute. 0.6 times X is 0.6X. And 0.6 times 12 is 7.2. Now we can go ahead and get rid of one of our X's. Remember, this is a 1X. So the 0.6 is the smaller one. I'll subtract it. So over here I have the 5.76. 1 minus 0.6x is 0.4x equals 7.2. And we'll solve from subtracting the 5.76. So 0.4x equals 1.44. Dividing by 0.4. X equals 3.6. Does that look right? Yep, 3.6. So that is saying is we would add 3.6 liters of pure antifreeze to increase that percent. Now this problem is a great stepping stone to the next variation of this problem. Normally, you don't just have free reign to add as much antifreeze into a cooling system as you want to. There is a set volume that that cooling system has, and you can't go over it. So let's just say we have a 12-liter cooling system. Testing at 40%. On the realistic side, you can't just add to it, it's full. So what we're going to ask is how much needs to be drained and replaced with pure antifreeze. To increase it to create a 60% mixture. So here again, we do have our ingredients. This time will be 40%, and the pure antifreeze is going to be 100%. And we're still shooting for a 60%. Now, however, the 12 liters is not the amount of the 40%. The 12 liters is going to be the final amount. That's how much the system holds. Now, it's starting out with that much 40%, but we're going to drain some of it out and replace it with pure. So the amount that we're going to drain and replace is the amount of the 100% of the pure antifreeze that we're going to add. What's left of the 40% will be 12 liters minus however much we have to drain out and replace. So now that equation, 0.4 times 12 minus x for 40% plus 100% will be 1 times x equals 0.6 for the 60% times 12. So 0.4 times 12 is 4.8. 0.4 times negative x is a negative 0.4x. 1x is just 1x or x. And 0.6 times 12 is 7.2. So over here, all we're going to do in the first step is combine the negative 0.4 and the 1 to get a 0.6x equals 7.2. Subtracting 4.8. So 0.6x equals 2.4. Dividing by 0.6. X equals 4. So now again, let's go back up, make sure we see what x is. That is 4 liters, because our other amounts were measured in liters. So we would have to drain 4 liters from that system and replace it with pure antifreeze, 100% ethylene glycol. Any questions? Okay. Now there are other variations of these problems you may have seen. You may have run into a variation of investment problems where, let's say, you're going to invest $12,000 in a mixture of 8% and 12% investments. At the end of the year, the total gain was $1,080. How much was in each investment? So this is a very similar problem, almost identical in nature. Now I worded this as you gained the $1,080 in interest, of course. I could have said your total gain averaged out to be 11% or 9% or whatever. And we could find that $1,080 off of that information. And if we have time, I'll do one example like that. This is very similar to our solutions and mixture problems because it follows the same thing. The principal times the rate equals the interest. Now, if any of you are familiar with simple interest, you'll notice that simple interest is P, R, T, where T is time. I left out the time because this is at the end of 1 year. So time is simply 1 year in this case. So when it's 1 year, the interest amount is just principal times rate. And I'm going to adjust that to fit more towards our model from our solutions as rate times principal equals the interest. So just like with our mixture problems or solution problems, we have two ingredients. We have 8%. We're combining that with 12%. And in this case, we're getting just a dollar amount of $1,080. How much of each did I combine? Well, it doesn't say. But we do know that we put $12,000 total into this investment. So if I let one of the amounts be X, I always go with the higher percentage, usually for X. So 12%, I'll let the amount that is invested in there be X. The amount that's invested in the 8% then is 12,000 minus X. And now we're going to just plug this in like any other mixture problem. So this percent of 8% becomes 0.08 times 12,000 minus X. Plus 12% is 0.12 times its amount of X equals, now here we weren't given a percent, so we don't have to do a percent times the 12,000. We were given what that amount was after the percent, just the 1,080. So that's all that goes here. We do not need the 12,000 in our formula anywhere right now. So 0.08 times 12,000 is 960. 0.08 times negative x is a negative 0.08x. Plus 0.12 times x is 0.12x equals my 1,080. So now 960 isn't going to change. I'm going to combine my x's. Negative 0.08 and 0.12 is 0.04. So now, subtract 960. Oops, did we lose Medford there? Looks like you guys froze up on me.
Can you hear us?
Yeah, we can hear you, but your image just froze.
Oh, okay.
Can you guys see me okay?
Yeah, we can find it.
Okay, that's good. We'll just keep going then. Okay, so we can subtract 960 from each side. We got 0.04x equals, what's that, 120? Divide by 0.04. X equals 3,000. So again, we have to make sure we answer the question. X was the amount put in the 12% investment. That would be $3,000. 8% was 12,000 minus X, or 12,000 minus 3,000, giving us $9,000 in the 8% investment. Okay, well, let's move on just a little bit from there. Just do a little bit other review with solving these equations. Now that we've done the mixture problems, those do a lot of our parentheses and stuff in them, but there are a couple of versions of it that I do want to put out there. Let's just try an example like this. So if we're solving an equation like this, obviously there are things that need to be simplified on both sides of the equal sign. You know, so far we've done our simplifications just straight across the board, but if there are a lot of things that need to be done, we can go ahead and just simplify one side first, get everything simplified, and then move over to the other. So here on the left side, I see parentheses, which should always draw us in first. Is there anything that can be done inside those parentheses? No, there's not. So we have to look and see if there's anything that needs to be done to the parentheses. That's going to be times the 7. So now 7 times 2x is 14x. 7 times 5 is 35. Now we still have the minus 4x. So now there's more I can combine here, so I'm going to go ahead and do it. 14x and negative 4x make 10x plus my 35. Now that I've simplified the whole left side as much as I can, now I'm going to go over to the right side. Over here again we have parentheses. There's nothing I can do in there. So I'm going to multiply by the 5. 5 times 6x is 30x. 5 times negative 3 is a negative 15. We still have the positive 4 there. So now there's nothing we can combine with the 30x. But we can combine negative 15 and positive 4 to make it negative 11. Now we're going to solve the equation, but we still have an x on each side. So I'm going to get rid of the smaller one, the 10x, by subtracting 10x. 35 equals 30 minus 10 is 20x minus 11. And then we'll add the 11. 46 equals 20x, and divide by 20. So we get 2.3 equals x. So this one wasn't too bad. It just added a few more steps in than what we've seen before. The ones that start to trip people up might look like this. When we go to do this one, the biggest thing we have to be careful about is that right there, the -3. We have to make sure we don't miss that. So let's go ahead and start simplifying. Over here, again, nothing to do in the parentheses. So we're going to multiply by the 5. 5 times 3x is 15x. 5 times -2, -10. So now over to the next set of parentheses here. Again, that's not times 3, it's times -3. So -3 times 2x is -6x. -3 times -7 is a +21 equals 32. Now we're not going to solve this all the way. I'm just going to combine here, and I'm going to trust you guys can take it the rest of the way. 15x minus 6x is 9x. -10 and +21 is +11 equals 32. And I'm going to trust you guys can take it from there to get your 2 1/3. The reason I showed you that example, you might be looking at thinking, well, why was that such a difficult one? Well, because we can now run into things like this. Oh, let's see here. What's that going to be? When we go to solve this one, it doesn't look that bad, but we have a negative here in front of our parentheses. We have to interpret that as a -1 times our parentheses. So the first thing, and then some of you may have been taught you just take out the negative and change the sign of everything inside there. That works as well. And that's just a way of doing the action without showing the -1. So when we simplify this, the 7x is not going to change, but we're going to do -1 times everything in the parentheses. So -1 times 3x is a -3x. -1 times -4 is a +4 equals 16. So again, 7x minus 3x is 4x. Still have the +4 equals 16. And I'm going to trust you guys can finish that equation off. Okay, well, with that is pretty much all I have for you for today. I do want you to keep looking at those mixture problems. Page 53 through 54, 1 through 15. This is, I will tell you, even in the high school group, the questions on the mixture problems are the most commonly missed questions on test 2. Just so you're prepared. Like I said, this Friday, since 2 of you guys are not in session, we'll go over the test and I'll record that for you. Just to give you an idea, next Monday then we'd be covering solving equations, complex equations with fractions, and evaluating some expressions and stuff like that. We'll go over a body mass index formula on Monday. Next week, Wednesday, we are not in session again. Friday, we'll do ratio and proportion. Just trying to get an idea of when we're going to end this one. Then the following week, we will be looking at scientific notation, powers, roots, measurements. So we got about 2 weeks left. Actually, it's probably going to be after spring break before we get to our next unit test. We're pretty close to it. Okay, well, with that, I'll let you guys go for the day. We will see some of you on Friday. Otherwise, the rest of you will see on Monday.